Hello, I'm Siona Bose. Welcome to my channel, Learning Builds Life, and today we are going to talk about covalent bonds. So this is just like more on covalent bonds. I will show some examples in which we learned about the sharing electrons theory of covalent bonds, sharing of electrons, which occurred in the covalent bonds. So I'm just going to give some examples of this via diagrams. Firstly, very simple, H2. Let's say, like here I'm writing H, but it's actually the nucleus and there is only one shell. Now, to fulfill the valencies of both of those hydrogen atoms, we share electrons and then it be like this. And I told you many ways of representing H2, like the formula itself, the structural formula, which was an H-H, like this, H2, H-H, or we could even use the Lewis dot structure, which was like this, H colon H, but it's actually not colon. Like that we can represent H, this is H2. Now, O2, that's the second shell, that's the first shell, and that's nucleus, and another one. Just a minute. Yes, these two are oxygen atoms. Now, how is the sharing of electrons happening here? So here we can see here, this bear, sorry, the inner shell, the first shell, capacity only 2 electrons for both. Here also both of them, the 2 pairs will be there. Now, where is the sharing of electrons? So we know there are 6 valence electrons in oxygen. So here, 1, 2, 3, 4. 2 from here, 2 from one of them, and 2 from the other one get shared, and it forms like this. Sorry. It has to be a little bit closer, like this, the overlapping. Yes. So over here, it forms a double bond like we discussed previously. Or O2. Now, water. First we have to make the oxygen. Weird circle. There will be 2 hydrogens attached to this oxygen atom. Both are sharing electrons, and ultimately the oxygen, the hydrogen, and the other hydrogen atom will fulfill their required valencies, or the capacities of their shells. A little bigger we can make the... Yes, that's more like it. Here we have an H, and here, this is actually a nucleus. This is O, but it's the nucleus of oxygen atom. Now, here obviously 2 electrons in the first shell. Now, how is the sharing occurring? Obviously from hydrogen, only 1 electron, only 1 electron sharing happens here, and 1 from here, and the same, 1 more from oxygen, and another here from hydrogen, and again those 2 other pairs. So what is the count? For oxygen, since there are 6 valence electrons, we have 1, 2, 3, 4, 5, and 6. But after the hydrogen came into being, then it happened like 1, 2, 3, 4, 5, 6, 7, 8. So that was fulfilling the capacity of the outermost shell, or the valence shell of the oxygen atom, and also the hydrogen atoms. This is H2O. And finally, methane. So in the center there is a carbon atom and a little bit smaller. So inside we have obviously 2 electrons in the first shell of carbon. Carbon has 4 valence electrons, and here there are 4 electrons from each of the 4 hydrogen atoms. So the sharing occurs like this. This is CH4, methane. Now you may take a look at the board. Next, we will discuss about electronegativity and types of covalent bonds. Let's continue. Firstly, in this sharing of electrons, actually, we need to understand compounds consist of 2 or more different elements. More different elements. In these compounds, we have to identify the type of covalent bond. This is where electronegativity comes. Electronegativity. Electronegativity means the attraction. It's the attraction to the sharing electrons. Attraction of the sharing electrons. Electronegativity differs. So let's say any compound has the electronegativity of those 2 elements same, like almost similar. Like for example here, H2 or O2, they have no, the electronegativity in H and H is same and O is same. So there is no tug-of-war for electrons. Therefore, there is a nonpolar covalent bond. But in case of water, let's say H2O, let's say if I'm drawing like this, like how I represented that diagram in the previous screen of those, the circle. Wait, this is a mistake. Sorry. The O should be there in the center, and here the H. Here, actually, O's electronegativity is oxygen is one of the most electronegative elements. So, and here H is like compared nothing in electronegativity to oxygen. Obviously, most of the time the sharing electrons will stay near the oxygen's nucleus because of the high electronegativity of oxygen, which leads to it having a partial negative charge, which is represented by, firstly, the bonds are called polar covalent bonds. Polar covalent bonds. And over here, actually, the oxygen attains a partial negative charge, which is represented by delta minus. And the hydrogens attain a partial positive charge, which is represented by delta plus. So this is partial negative charge. Negative, and this is partial positive. Now I may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you!